All right, so the question this time is, how many grams of potassium carbonate are needed to make 200 milliliters of a 2.5 molarity solution? So step one, identify given information, and it asks you how many grams. So grams is a mass, and I'm going to say that's what we're looking for, of potassium carbonate, and we'll write the formula for that right now. It's K2CO3. And if you're unsure on how I came up with the compound formula, I have videos on writing compound formulas, so you should check those out. And next piece of information we're given is that we have a volume of 200 milliliters. So here I'll just write V is 200 ml. And lastly, we have a molarity of 2.5. So uppercase M is 2.5. And I'll just write another one. Okay, so we're looking for a mass and we're given molarity and volume. And the next step says apply the math or physical laws that relate the given information. And based on everything that we've been given, you can see molarity is a fitting formula to use. And it says molarity equals the amount of moles over the volume in liters. And we're looking for grams, but we know that grams and moles are related to each other, so if we find the moles, we'll be able to convert that over to grams. And we've been given the molarity and we've been given the liters, so now we have a path to take to be able to find the grams. So we're going to solve for moles and convert that over to grams. So in order to do that, we're going to have to change this equation a little bit. I'm multiplying by liters. The liters on this side of the equation cancel, and your new equation is moles equals molarity times liters. Okay, so in order to do this, we have to convert the volume over to liters, and we have 200 milliliters, and I'll put that over 1. And now the ratio that relates milliliters to liters is 1 milliliter equals 0.001 liters. After you do the multiplication, you'll see that liters cancel, milliliters cancel. You're left with liters, and that equals 0.2 liters. So now we have everything we need to plug into this. So this will equal 2.5 molarity times 0.2 liters, and that turns out to equal 0.5 moles. So now that we have the moles, last thing we need to do is convert the moles over to grams, and we'll have the answer to our problem. Now, we have the compound formula here, and we have to take that and the moles that we were given and find the relationship between the moles and the grams. So the next step is saying look up element masses. So we have potassium, we have carbon, and we have oxygen. So for oxygen, we have 16.0, and that's being multiplied by 3 according to our compound formula. Then we have carbon, that's 12.0. That's only one of those. It's not being multiplied by anything. And then for potassium, we're going to use 39.1, and that one is being multiplied by 2. So the total potassium is 78.2 grams per mole. I'll just write carbon again. It's 12.0 grams per mole. And for oxygen, we have 48.0 grams per mole. So the total mass of potassium carbonate turns out to be the sum of everything that we found here, and that's 138.2 grams per mole. So now we found a relationship between grams and moles for potassium carbonate, and we'll be able to convert the 0.5 moles over to grams. So let's do that. We have 0.5 moles, and similar to the conversion we did over here, I'm gonna show the division of 1 on the bottom, and let's write our ratio for that relationship. We want to get rid of the moles, so we'll put moles in the bottom. 1 mole is equal to 138.2 grams. After we do the multiplication, moles cancel. You're left with grams, and you are left with 69.1 grams as your answer. So I hope I was able to help, and if you need more practice with molarity type problems, I have other videos on the concept, so check those out. Until next time, take care.